Hello guys, imagine controlling your fan speed directly from your phone. No remote, no Wi-Fi, just Bluetooth. In this video, I'm going to show you how I built this smart DC fan using ESP32 controller. And the crazy part is it even remembers the last speed after power off. You can set it to low, medium, high, or even choose any speed you want. Let's build it step by step. Let's get started. Hello guys, welcome to Gatronics, where we turn tech concepts into working systems. Here before me is a DC fan and it's Bluetooth based. Use the Bluetooth to control the switching on and switching off. Not just only that, you also use the mobile phone via Bluetooth to give it a low speed, medium speed, or high speed. Now, for the hardware components used, let's quickly look at that. Alright, there's DC fan 12 volts. You can see 12 volts. This one is required for it to be powered. You have your controller, this is the brain box of the system. I've used pins 25, 26, 27. As you see in the code, watch my previous videos on how to use this if you are a beginner. Then here is the motor driver L298. You can control two motors at the same time. You can control two DC fans at the same time. In this design, I've only controlled one fan. That's to say, I usually output 1 and output 2. Here, you bring in an adapter 12 volts with enough current rating. Like the one I use is 5 amps. That's why it's able to send 5 volts, enough current to power ESP32 as a controller. In your case, if you can't get that, and you're bringing any 12 volts adapter less than 5 amps or so, make sure you give external power to ESP32 because it will help you to have enough current. When you are doing that, make sure they have common ground. Okay, because I control only one fan, I didn't bother using output 3, output 4, enable pin B, in 4, and in 3. I only used in 2, in 1, and ENA. Right, but watch out. You can see a cap here, like a switch is making contact, making ENA to join with VCC inside internally. And when you do that, if you leave it this way, you can't control the speed. So I had to remove this. You need to remove it so that the connections are made on the controller. The code I'll be dropping, control it exactly the way it should be. Okay, here is the circuit diagram from Produce. Just made it to illustrate. You may not find exactly like this on the Produce. You need to install the library for this ESP controller. Then the job for schematic, you can simulate at this. It doesn't have the feature for now. The model for simulating this ESP32. So that's that. What else? I think there should be connections. Okay, the basic connections I did in one to JP25, GPIO 25, GPIO 26, GPIO 27 for PWM, that is pulse width modulation, the one that controls the speed of the fan. If it's motor, the same thing applies. Because we are not controlling direction, I just left it at high and low for this in 1 and in 2. I concentrated on here. In 27, I control the speed based on the commands which you will see in the demonstration section. So everything here is self-explanatory. You also need to see these two. This covered every control that you need to know, and every control you need to know is here. You can see Bluetooth plus speed control plus memory is simply telling you that this memory now is, if for instance the fan is working and all of a sudden you have what is it called? Either the battery goes down or there is power outage, If power is restored, it maintains the previous speed. Was as for it which were on medium speed and that runs down or power outage occurred. When you now power it up, it goes back straight to medium speed. That's one thing. It's a very unique feature it has. What else do I need to show you before I quickly go to the code? Okay, these are the commands, Bluetooth commands you'll be using. If you send high, it runs at full speed, medium at medium speed, low at low speed, off, the fan goes off. Then quickly on the code, we have, okay guys, for the software part, let's see how it goes. Um, I need to explain some key points. Arduino header, we need it so that any function we are calling pertaining to Arduino programming protocols will not be seen as errors. Then Bluetooth serial.h is helping us to make the app compatible with our system. We see it, any function we are calling will not be seen as error to the system. And there is a preferences. This does the work of EEPROM just as we have it in Arduino controller. So it helps us. Remember when I explained about the system be able to remember previous state. Let's say it was originally running at medium speed and all of a sudden the power goes out or the battery runs down. By the time the power is restored or is charged up, the battery is charged up, it maintains the previous state. That's particularly what it's doing. Then for the pins 25 and 26, I would have used them for direction, but I don't need direction in this condition. I'm just controlling the speed of the fan. Therefore, I just allow them to remain in one direction. Just pin 27, the GPIO 27 that I use for what? Speed using PWM technology as a pulse width modulation. Then first one, yeah, this is why I declared the two terminals to remain in one direction so the fan doesn't change direction. I'm interested in the speed. If you want direction changing, we also recommend it for me so I can make the video. I'm here to assist as many as you are ready to learn. Even if you're already a professional, you also make your contributions. So that's why I set the pins as outputs because I don't need to stage them in one direction. More control is needed. So okay, line 93. If you want it to be another name, the Bluetooth is where you change it to your test, whatever name you want it to be. That you can play around with that. Okay, let's compile our code and see. Okay. Alright, done compiling. Let's go to the board and select the one we are using. So go to tools. Here is the tools. You go to board. Here you have some options from ESP32 dev module, ESP32 ROM dev module, program module. I selected this actually. Then you also check for ports. Select the ports. Okay, let's plug our smart system on the laptop and select the port. Yes, you can see now that the port is not showing. Then let's connect it. You see the difference now. Here, as a sign that something new has been connected. Oh, automatically it picked because I've used it on this computer before, but in your case, it might not be checked. So you need to what? Select it. Now hit the upload button. Okay, uploading has begun. Oh, excellent. Done uploading.
Now, it's a 12-volt system. This adapter is a 12-volt 5 amps. So, when you connect, it is rechargeable too. So, then you plug it right. After that, what do? Pick your phone. So, pick your phone. You go to your and find the name. Oh, you can see the name here is a smart DC fan. I tap it, it's going to appear now. Just be watching. Oh, that's good. And but even before that, you should have gone to what is it called, Play Store, to download Bluetooth terminal. You search for one. I will show you the logo now. Bluetooth terminal. Bluetooth terminal. Bluetooth. Let's see if it's this. Bluetooth. Let's see. Bluetooth terminal. Very good. You can see it. I've downloaded it, so that's why I don't need to download again. Just to open it. So I need to open it right away. It will take you to this interface. You click on these three dots. You select it. Oh, connected already. Let's see how the commands will go now. Let's give it a low speed. Can you see it? Enter the low. Let's give it, can see now. Let's give it a medium speed. Can see me typing medium. Can see medium there. Okay, let's send medium. I hope you can notice that the speed is changing. Okay. The highest is to send high. To send high speed. Now high. Let me send high. Wow. Running at the highest full speed now. Wow. I use a lithium ion battery. When we send off now, it goes off. You can see me typing off. Let me send off. It is not beautiful, man. So the circuit diagram, the code, all you need to get this kind of project done is in the description below. Do well to subscribe, hit the notification bell so that more videos be dropping.